Hi, welcome to Video Math Lessons. Tonight we are doing a pre-calculus Math 12 class. The topic is polynomials, and the lesson we're going to go over is end behavior. So the first thing we have to do is we got to talk about what end behavior is. Now, end behavior is what is the graph doing at the ends. So that's what we have. What is the graph doing? Well, that seems kind of simple. So let's get a little more techie. So as x goes to infinity, so erase that. As x goes to positive infinity, and as x goes to negative infinity. So what we're going to do is we're going to use terms. So we use the term limits. And this is how we're going to write it. So it's going to say the limit, and underneath we say is x goes to infinity of f of x, or not or, we're also going to do the limit as x goes to negative infinity of the function f of x, or g of x, or h of x, whatever the function is. And what we're going to do is we can either use the graph itself, or you can use the equation if you know what the parent function looks like. So we can use the graph, or just the equations. Now, we've actually done end behavior, but we never really did like an official thing in class. So we've used end behavior when we were looking at at a graph, and we talked about even and odd functions. So when we say as x goes to infinity, we're talking about all the way this way. X goes to positive infinity. So, and then we say x goes to negative infinity, we're looking all the way to the left. So if we have just some polynomial here, let's go like this, right? Some function, right? And it continues on that way forever, and it continues that way forever. So it's just a polynomial function. In this case, we're calling it f of x because that's what it says. It's called f of x up here. And so when I say the limit as x goes to infinity, I'm talking about if this graph keeps going in this direction, where's the graph heading? This graph is heading down. It's heading down towards negative infinity. So what's the limit as x goes to infinity? The answer is negative infinity. Let's look this way. What is the limit as x goes to negative infinity? Where's the graph heading? So, and when we head this direction to the left, the graph is going up to positive infinity. So where's the limit as x goes to negative infinity? The answer is positive infinity. And that's pretty much it. So let's take a couple problems here. So let's just draw one here. So on your paper or in your notes, let's do something like this. And we have two parts here. So the limit is x goes to infinity, limit x goes to negative infinity. And sometimes they'll just say describe the end behavior. They won't give you the limits. They won't give you the direction of the limits. So as x goes to infinity, as we head to the right, the graph is going up to positive infinity. What's the limit as x goes to negative infinity? Well, the graph is heading up again. So the answer for both of them is positive infinity. So here's two problems. G of x and f of x. Now, on the worksheet, I don't think you have the limits written for all of them. So you're going to put the limits on each one of these. I just did it to save time. So So if we think about this, let's look at this first graph here. So it says negative 2x to the fourth plus 3x cubed plus 5. So like, let's say we forgot, we're like, oh, I don't know what this graph looks like. Well, you can always use your calculator. Now the goal is to be able to do these without a calculator. So just to get started, we'll use a calculator and just make sure we can punch it in. Negative 2x to the 4 plus 3x cubed plus 5. And we'll hit graph. And since this is a fourth power, I'm thinking it's like some kind of a W shape. Since it's negative, it's going to be an upside down W, something like this. So that's what I'm thinking. We look at the graph. It's kind of banged up here in the middle, but it's a general shape. Even powers will point the same direction. Odds point opposite directions. So as we look at this graph, as we go to the right, the graph is pointing down. So the graph will be going towards negative infinity. As we go to the left, the graph is going to also go to negative infinity. Question number 3. Negative x cubed plus 3x squared minus 2x plus 2. Usually a cube would look like this, something like this, right? This would be positive cube. So the negative should go something like opposite. Well, let's check it out. We'll just try it. And then once you actually get more comfortable with it, you won't be using the calculator for these. So negative x cubed plus 3x squared minus 2x plus 2. And we hit graph, and it, right, so negative goes like this, something like that. So as we go to positive infinity, so as we're going heading this way, as we go this way, the graph is going down, so it's going towards negative infinity. And as we go to the left, the graph is going up to positive infinity. That is the end behavior. Let's try 2 more. Now, let's think about this now. Look, they broke it down to a series of factors for us. So what I could do is just say, all right, let's just look at what power, what degree would this problem be. So if it's 2x times x times x, the lead coefficient would be 2x cubed. I really don't care about the rest of it. So I have a feeling if I actually graph this whole thing out, it would look, since that's a cube, it's going to be something like this. The positive 2x, so it's going to look something like this. Now, this is one of those weird ones. So this was, when we first trying these, is something that you're pretty good to try out. So just punch it in. Make sure you use parentheses. Be careful. So 2x plus 1. And then hit graph and then see what you get. And it is something like that. It's off the screen, but it's the general shape. So as x goes to infinity, right, as we go to the right, the graph goes up, positive infinity. As we go to the left, the graph goes down to negative infinity. So let's try this again. Now, you might be tempted to say, well, it's x and x is x squared. But we have these exponents on it. These are called multiplicity. So it's not really x plus 1 times x minus 2. It's x plus 1, and x minus 2 3 times. So if you actually multiply this out, this would actually be an x to the 5th problem. Now let's check that out. So if it's an odd power, it's going to be very similar to this graph. It's going to look something like this graph, but a little more banged up in the middle. So in the general shape, though, one side go down, one side go up. It's actually, I think it'll be pretty similar to this graph. So this is another one I would like to try, just plug in, just to make sure. And make sure you use your parentheses again. And we hit graph. And it is something like that. Notice that little banged up part right here? That's just from this, being a 5th power. So let's write this one as the limit, as this time we have h, as x goes to infinity of h of x. It's going up, so it's positive infinity. As the limit, as x goes to negative infinity of h of x, it's going down to negative infinity. And that's pretty much it. We can do end behavior with all the other functions also, and rationals, which we'll talk about in class. Well, if you need more examples, Purple Math is a nice website. You can check them out. We have more examples of end behavior. And that's about it. So thanks. Bye.